Hello, am I audible to all?
Yes, ma'am.
Okay. So students are still joining, right? Okay. So in the last lecture, actually, we have seen the transformer protection. So in transformer protection, we have seen the different types of faults which are occurring in transformer. Then, what are the schemes to protect this transformer? So we have seen the differential protection scheme of transformer. So that is very important. This is frequently asked in examination. Okay, and today we are going to see the generator protection. So all of you know about generator. So how, and we have to see how actually this generator is protected. Actually we are seeing here uh, again the MERS price protection scheme, that is nothing but the differential protection scheme. Yes, so when I maximize the screen automatically, uh, okay, it's not getting maximized. It becomes blank here. So I'll share screen as it is. You can zoom that. Okay. Uh, so in last lecture, we have seen this transformer protection. So in transformer protection, there are different faults. Okay, and for protecting these transformers against different faults, we are using relays. Okay, so now this is the scheme which is used for the protection of transformer. That is the percentage differential protection. Okay, so this is the diagram for that. Remember this. It is very important and used for this not only transformer but for the generators also. Okay. Then we have seen this harmonic restraint differential relay and then Buchholz relay for incipient faults. Buchholz relay you already studied, so simple, and protection against overfluxing. Overfluxing means if the flux uh, uh, starts producing, okay, after saturation of core, means that when the core will saturate, then also if we are giving excitation and uh, uh, that flux after saturation, actually fluxes are not producing, but uh, when we are exciting the core, that time it will get uh, damage, okay, due to the overcurrent. Okay, so how to protect the transformer against this overfluxing, that is given there. Then next point is the generator protection. Today we'll see the generator protection. So this generator, all of you know the generator. Okay, so we are using this generator at all the generating stations. So actually, for this generator, if we consider, I cannot use here pen also. Just wait, I'll once again check whether it is full screen. Now visible? नहीं है ना? Yes, yes, yes. Done, done. Okay. Now here, all of you know when we are considering a generator, this generator is nothing but here we are giving the prime mover is there. Okay. First is the prime mover here. Okay. Then here we are connecting to the grid system. Okay, and here is your generator. Here is your generator. So the prime mover supply is given to this generating unit, and it is connected to this grid. It is connected to the grid, and also DC excitation is also given here. Okay, DC excitation is also given for the generator. Okay, now here what actually happens when we are protecting this generator? This protection of generator is considered as a very serious, okay, or whatever be, it is very complex. It is very complex. So whatever be the faults occurring in this generator are taken seriously, because when it will fail, uh, means the synchronism is failing, then it is affecting the whole power system. Okay, because at the generating station only the fault is occurring. Okay, the fault is occurring. So if there is any fault in the transmission line or in distribution line or in any transformer, we can simply disconnect that part only. Okay, means for a particular section only we can disconnect the power supply. But if the fault is occurring at the generator only, so the whole line supplied by that will fail. Okay, actually we are using the different generators. Okay, means just like backup protection, there are different generators which are used because in our power system our load is varying continuously, right now. We are not using the same load in the morning, in the afternoon, and in the evening also. Okay, our load is varying. So according to that, our generating units are also varying. Means we are just switching on and off there. Okay, means in the morning and in the evening yes, time, uh, the more generators are switched on there, right? And in this afternoon session, means these are switched off, so that there is no loss of these generators. Means if means we are not all units are not providing the continuous, means that much power supply only. Okay, म्हणजे सपोज तुम्ही संध्याकाळी आणि सकाळी सपोज इन जनरल यू आर युजिंग सपोज 100 power. Okay, so 100 suppose it is kV. So whatever be the supplied units will be not that much only. Okay, for your whole day. So for afternoon session these are different, and for morning and evening sessions these are different. Means your whole system get affected if there is a fault in the generator only. If there is fault in the generator, so when we are using generator and if any fault will occur, so that is due to the prime mover. Okay, so if there is failure in this prime mover, okay, or uh, so it will affect, but more effect is on this grid and due to this DC excitation also. Okay, so in this generator protection, in the size of this individual generating units is 30 megawatt to 500 to 1000 megawatt. Okay, this is the generating unit capacity. Then loss of even single unit is a serious problem. Okay, means as I told you, now there are number of units, right now number of generating units are there, and if a single unit will fail to operate, okay, means if there is loss of a single unit only, there will be a serious problem, because from this generating, if there is fault in generator only, you cannot transmit and you cannot distribute here. Okay, so if there is a fault in the suppose transmission line, there is a fault, you can simply disconnect this much section only. Okay, and you can supply by using the backup protection. But same for the distribution also. Okay, but it is not case for this generating station. Okay, means there are number of generators also. Okay, we are using this, but if at a peak time only, that is in the morning and in evening time only, if it fails, then the whole system will collapse here. Okay, so this is a loss of a single unit is a serious problem and required to reduce the outage period to a minimum time. Okay, so uh, uh, so this generator protection required to reduce the outage period to a minimum. Okay, means whatever be the time required for the fault clearing. Okay, so that will be minimum if we reduce this or if the fault occurring in this generator, then it is achieved by a rapid discriminative clearance of all fault conditions associated with the units. Okay, so we can uh, we have to uh, means clear these faults as early as possible, and damage due to faults is none or to the minimum. Okay, and if we clear these faults, then there will not be any damage, okay, due to these faults, and or it can be minimum. So there are different faults which are occurring in this generator, and mm, again here we are using a differential protection scheme. So there are different aspects of this generator protection. So first, that is fault classification. So there are number of faults in occurring in generator. These are the internal faults. Okay, so in generator, which windings are there in generator? Again, there is stator and rotor. Okay, so uh, windings are there. These internal faults are nothing but the interturn faults and the core faults. Okay, interturn faults means whatever be the windings are there. So these are the winding faults and the core faults. Okay, then abnormal service conditions. Okay, abnormal service conditions. Then external faults, and the hazards and problems considered here means any if any sudden hazard is there, so this can also be considered as a fault only. Then face to face faults in winding. Okay, means if any two of the windings get short circuited, then that is called the face to face fault. And face to ground faults, so face to ground faults means it is a single line to ground fault. Then ground faults in the rotor. So ground faults means all ground faults. You can consider there the double line to ground fault also, means whatever be the ground faults occurring in the rotor. So these are the faults, different faults which are occurring in this generator. Okay, now here these are the abnormal conditions, means why actually these faults are occurring. Okay, why the faults are occurring here? So first reason is the loss or insufficient excitation. Okay, so for generator we need excitation. Okay, so if that excitation is not received, or if it is lost, then or insufficient, then your generator will fail to operate. Then second is overload. Okay, if the load on this generating unit increases than its capacity, okay, then also this generator will fail to operate. Then third is the over voltage. Okay, over voltage means suppose uh, that voltage is increased, okay, suppose the voltage increases than its rated value, suppose the voltage increases than its rated value, then that is the over voltage condition. Okay, then next is the under and over frequency. Means whatever be the supply frequency given, that is in our India it is 50 hertz. Okay, so if that frequency becomes low, or if it is more, if it becomes more, then also there will be fault in the generator. Okay, then next is the unbalanced current. Okay, unbalanced current means again the phase difference between these two phases will be different. Okay, actually it is 120 degree, but if that phase difference changes, okay, if the phase difference changes, then that is called the unbalance. Okay, means when we are considering the three phases unbalance, when we are considering three phases of this current, of the current. Okay, and if actually this is the balance condition when angle between all three phases is equal to 120 degree, but if this angle changes, then uh, uh, that current get unbalanced. Okay, then next one is the out of step or loss of synchronism. Synchronism means what? Loss of synchronism means what? Okay, means what? Actually, if the mm, whatever be the steps are there given, okay, for the operation of transformer. So if any one of the equipment fails to operate, okay, then there will be loss of synchronism, means others will also fail. Okay, so that is called the loss of synchronism. Then loss of prime mover. Okay, means if there is any failure in the prime mover, okay, means whatever we are using different turbines. For example, we see the turbine in the hydropower plant. Okay, so if there is loss of this turbine, means if any fault will occur there in that turbine, then that is also considered as a abnormal condition. So whatever be the faults which are occurring in this generator, these are due to these abnormal conditions. Okay, so faults occurring in this generator are phase to phase faults, phase to ground faults, right? Then which faults are occurring? Phase to phase to ground, then interturner, means what it is called? It is called the internal faults. Okay, internal faults. So there are different faults occur, and uh, the reason behind that occurrence of fault is the abnormal conditions, and these are all are the abnormal conditions here. Okay, so remember this. Now the next point is the stator earth fault protection. So actually, what is stator earth fault protection? We are going to see the differential protection of transformer, but this is given only for your understanding. Okay, understanding purpose. Here you can see the general scheme. This is a restricted earth fault protection scheme is given with over current relay. So a detailed diagram is already there. So we'll see that here we are using over current. The generating unit is there. Okay, and here we are using the current transformer. Here only one winding is shown actually, and these are the relays. Over current relays are there, which are connected in each phase of these cities, and there is one earth fault relay. Okay, one earth fault relay means if any fault will occur, that time this relay will operate. So you can see here, this is the star connected. Then it is grounded. It is first grounded here, and this secondary is given to this city secondary here. Okay. So here the star point or neutral point of stator winding of an alternator is grounded through an impedance to the to limit the ground fault current. Okay. Uh, um, what we are doing? We are connecting this star point. Okay, star point or neutral point of our stator winding, uh, which is grounded through an impedance uh, which is having some lower value. Okay, to limit the ground fault current. Means when any fault is occurring here, so this is the uh, ground connection here, and you can see the star connection. Okay, star connection. This is your mm, mm, generator winding is shown here. Generator is there, and its star connected point is again impedance or through the impedance. Then reduced ground fault causes less damage to the stator core and winding during ground or earth fault. Okay, so if reduced ground fault current, okay, reduced ground fault current, so it will cause less damage. Means if when we are using the impedance, what will happen? It will again oppose the flow of current. So what actually happens when any fault will occur, so that time there should be some protective device, right? So if that current will occur, that current should uh, mm, sorry, when that fault will occur, that current should pass through that earth. Okay, through the earth. So we are using the low impedance there. We are using low impedance so that the maximum current will flow towards the earth only. Towards earth only. Now, so this reduced ground fault current causes less damage to the stator core and binding during ground or earth fault. Okay, means as I already told you that face-to-face faults are more severe than the ग्राउंड फॉल्स. ओके, म्हणजे ग्राउंड फॉल्ट झाल्यानंतर फ्लो होणारा करंट हा थोडा कमी असतो, पण जेव्हा फेस टू फेस फॉल्ट होतो त्यावेळी तो करंट जास्त असतो. ओके, जास्त असतो. फ्लो झाला पाहिजे सो दॅट यू कॅन प्रोटेक्ट युअर सिस्टीम. ओके, so that's why we are using here the low impedance. We are using here low impedance. Okay, so so that our equipment can be protected here. That is the generator. Now if the ground impedance is made quite high, okay, is made quite high, the ground fault occur may become even less. Okay, even less than the normal rated current of the generator. Means if we are using an impedance of high value, then what will happen? Whatever be the current flowing towards ground will be less, and it can sometimes damage the equipment. So if so, the sensitivity of phase relays becomes even low. Okay, so your relays may become less sensitive, even they may fail to trip during fault. Okay, so this can be caused because we are using the high impedance here. Okay, so when we are using high impedance, these problems are occurring That's why we are using the low impedance, so that the maximum current will pass through that towards the ground. Okay. So this is the generator protection. Then next is the differential protection of alternators. So this is very important scheme, differential protection of alternators. So can anyone tell me about that? Yes, differential protection or differential. We have seen this in transformer also, differential protection of transformer also. What we are doing, we are simply checking the current passing through that operating coil. Okay, actually त्याची डायग्राम थोडीशी वेगळी आहे आणि याची थोडासा डिफरन्स आहे, बाकी सगळं सेम आहे. ओके, सो in this differential protection of alternators, what we are doing, we are again passing the difference of current through the operating coil, or here simply we connected the relays. Okay, so how it is, we will see that. But this type of protection or differential protection of alternators is also called as merge price circulating current scheme. Okay, so remember this, because sometimes they are asking the merge price protection scheme of an alternator. That time also you have to give the same answer here. Okay, you have to give the same answer. So what we are doing here, समजले, मर्ज प्राइस प्रोटेक्शन ऑफ अल्टरनेटर किंवा डिफरन्शियल प्रोटेक्शन ऑफ अल्टरनेटर, दोन्हीचं मिनिंग कसं आहे, सेम आहे. ओके, सो वी विल फर्स्ट सी द डायग्राम हियर and then we'll go for the explanation. Now here, hello, concentrate everyone. We'll see the diagram first. So here, hello, so here there is an alternator is there. Okay, so the three windings are there, which are shown for the three phases R, Y, and B. As we have to protect this alternator, on both sides of this alternator, we are using the current transformers. Okay, means this is for both sides, means whatever be the transmission line will be there for that side also, and to the windings also we are connecting the current transformers, so that if there will be any difference between the current flowing through that phase, so that difference will flow through the relay, so that your relay will operate. Okay, so here you can see now there are no actually just like the transformers, we are connecting this transformer in star or in delta. Okay, star and delta connections are there for the primary side and secondary side, but this is not the case for this alternator or for this generator. Now what is actually the difference? Okay, we are connecting this current transformers to the before this alternator and after this also, means we can connect that in star. We can connect that in star and also in delta. No issues here. Okay. So here we are connecting it in star. Okay. But when we are using a transformer, that time you have to check that if the transformer primary is connected in star, you have to connect the CT primary in delta. So means you have to change. You have to change because you have to obtain that phase difference. Okay. That's why it is connected like this. Now, what actually happens here? So first see this R phase is there. So CT primary is connected in how it is connected? CT primary star or delta? How the CT primary is connected? How the CT secondary is connected? Star or delta? Anyone? Star or delta? Yes, Kiran. CT current transformer, how it is connected, in star or in delta? Yes. Okay, it is connected in star here. Okay, and we are connecting this all the phases to ground. Okay, we are connecting all the phases to ground through this earthing resistance. Okay, through this earthing resistance. Now, what here also the CT secondary is connected in star here. It is connected in star and all the phases are connected to each other. So this phase of CT1 CT1 is connected to R phase of CT2. Y phase of CT1 is connected to Y phase of CT2 and B phase of CT1 is connected to B phase of CT2. Okay, and these are the pilot wires which are used to connect these cities. Okay, these are pilot wires used to connect these cities. Now, what we are doing, we are using here the differential relays. Okay, so whatever be the difference, means under normal operating conditions, what happens? Whatever be the current at the primary side, the same current will be at the secondary side. Okay, so this is your supply current. Okay, supply current, suppose, and this is your suppose load side current. So, and in between that there is a generator. So whatever be the uh, whatever be the supply, so whatever be the input current, that should be equal to your output. So if there is any loss if there is any loss, then what will happen? uh, then what will happen, means if there is any fall, there will be difference between these two currents. Okay, between these two currents, means suppose I'm just taking example. Suppose this primary current is of 50 ampere. Okay, so if there is no any fault, the same current should flow through the CT secondary also. That is suppose 50 ampere, or we'll consider only the 5 ampere here. Okay, so if I consider that the current flowing through the CT primary is also 5 ampere and through secondary is also 5 ampere. Okay, now if I consider that if fault is occurred, okay, so our first fault is the phase to earth fault. So here that fault is shown. Okay, here that fault is shown, that is single line to earth fault. Okay, or a earth fault is there suppose happening, then what will happen? So whatever be the current flowing through these wires or through these pilot wires will change. okay, will change. Means the current flowing, just tell me what will be the current flowing through the R phase. What will be the current flowing through R phase? It will increase or decrease? It will increase or decrease? Yes. If there is a ground fault, then what will happen? What will happen? Okay, so if any fault is occurring, your current get increased there. Okay, your current get increased there. So whatever be that current, means this is your 5 ampere, and now if the city secondary current will increase here, and that difference will pass through these relays. Okay, through these relays. Now here the fault is occurred in this R phase. So the current flowing through this R1 relay, okay, current will flow through this R1 relay. Actually, when there is normal operating condition, when no fault was occurred there, then what happened? The same current was flowing, means that was the normal operating condition. Okay, but if there is a difference between the current, that current will flow through that particular relay. Means this relay R1 is connected to R phase, R2 is connected to B phase, sorry, Y phase, and this R3 relay is connected to the B phase. Okay, so if the fault is occurring in this R phase, then your this R1 relay will operate. Okay, it will give signal to the circuit breaker for the tripping purpose. Okay, it will give the signal to the circuit breaker. So you have to remember this diagram. Now, similarly, we will see here the we'll see here the face-to-face faults also. Okay, so all of you got this earth faults, earth faults, yes or no? Okay, the next one is the face-to-face fault. In face-to-face fault, what happens here? You can see two phases. ओके, म्हणजे दोन फेज जर एकमेकांना शॉर्ट वगैरे झाला तर काय होतं? सो दॅट इज नथिंग बट द फेस टू फेस फॉल्ट, और इट इज ऑल्सो कॉल्ड line to line fault. Okay, so for that we are considering here the Y phase and B phase. So if the fault is occurring between Y and B phases, then the current increases too much, means that current will be more. So that more current means that difference of current will pass through this R2 and R3, these two relays, and these two relays will operate these two circuit breakers here. So when the circuit breakers get operated, okay, means that faulty section get disconnected. Okay, that faulty section will disconnect. Okay, so this is the working of your alternator, that is the differential protection, or it is also called the Merz price protection of the alternator. Okay, now we'll see in detail, that is the earth fault and the face to face fault. Suppose as we consider that a fault is occurred due to breakdown of insulation to earth, the current in the affected phase winding will flow through the core and the frame of machine to earth. Okay, and the circuit being completed through the neutral earthing resistance. Means how actually will be the direction of flow of current. So that is given here. Means when that phase to ground fault will occur. So we consider that there is a R phase. So, and that fault is occurred due to insulation breakdown. So, at that time, how actually the current will flow? How actually the current will flow? So, that current will flow through first the core of the generator and frame of the machine to earth. Okay. म्हणजे generator, all of you know the construction of generator. Okay, so it will flow through the core, then frame of that machine or generator, and towards the earth, because every machine is earth there. Okay, so the circuit being completed through the neutral earthing resistance. Now the currents in the secondaries of two cities in phase R will become unequal. Okay, means as I told you, when any fault will occur, what happens after occurrence of fault? The difference between the current is flowing through the relay. The difference between the two cities will be there, and that will flow through that relay. Means we are saying that the fault is occurred. So how actually that fault is occurred? Because that phase is grounded there. R phase was there, and that R phase is grounded there, and means whatever be the current flowing through the CT1 is different than the CT2, than the CT2 here. Okay, so means these currents become unequal, and the differential current will flow through the operating coils. Okay, so this is for the ground fault. This is for ground fault, because when this ground fault is occurring in R phase, so its difference of current will flow through the relay R1 only and returning via the neutral pilot. Consequently, the relay operates to trip the circuit breaker. Means when the fault current will flow through this relay, your relay will operate. Means this relay is nothing but here, this is the operating coil. This is the operating coil. There are two coils. One is the operating coil and second is the restraining coil. So when the fault current is flowing through the operating coil, that time only your relay operates. That's why this R1 is shown here, but it is nothing but the operating coil of the relay. Okay, and then whatever be the current flowing, that relay will operate the circuit breaker to trip the contacts. Okay, then next is the uh, face-to-face fault. Okay, so here we are considering that a short circuit is occurred between these two phases, that is Y and B phase. So the short circuit current circulates via the neutral end connection through the two windings. Okay, so how the that short circuit current will flow? That current will flow via neutral and connection through two windings. Okay, so the currents in the secondaries of two cities in each affected phase will become unequal. So which are the phases we are using here? That phase fault is occurred in Y and B phases. In R phase, earth fault is occurred. In Y and B phases, the phase fault is occurred. Okay, so the occurrence in the secondaries of cities in each affected phase will become unequal, and the differential current will flow through the operating coils of release. So as the fault is occurring between two phases, that is Y and B, now that differential current will flow through the remaining two relays, that is R2 and R3, because this R2 relay is connected to here for the Y phase, and this R3 is connected to the B phase. Okay, and the relay then closes its contacts to trip the circuit breaker. Okay, so the relay will close its contacts to trip the circuit breaker. Means now your circuit breaker will operate and it will disconnect the faulty section. Okay, so this scheme is important. The differential protection scheme for the alternator. This scheme is also called the Merz price protection of alternator. So just tell me if any doubt is there. Is there any doubt? Yes or no? Any doubt? No. Okay. Shraddha, Sangeeta,
Yes, ma'am.
any doubt?
No
समझ गए
doubt,
का?
ma'am. हो
Okay.
ma'am, समझ गई.
हाँ ठीक. Okay. So remember this circuit. It is used for the transformer protection also and for alternator protection. Okay, for transformer protection you have to draw here only the transformer. Okay, and here only alternator windings you have to draw. So remember this difference, and you are getting the marks. Okay, means marks distribution will be as per the question, but here the questions are same, like explain suppose the differential protection scheme of alternator if they are asking. Then in that you have to first draw the circuit diagram, then your construction, working, if there are any advantages, disadvantages or limitations are there in the and applications. In this way you have to write each and every question, and always there are marks for your diagram. Okay, so remember that. Means here in this diagram only your earth fault is also covered and phase fault is also covered. Okay, earth and phase fault both are covered. Now what is the difference between this? We are using the same scheme, that is the differential protection, right? We are using this for the transformer protection also and for alternator protection also. Okay. Hello. So sorry, call was there. Here, can anyone tell me the difference between the alternator protection and transformer protection? Means we are using this differential protection scheme. So what is the difference which we are using for transformer and for alternator? Can you see any difference? So you can see here. Can anyone tell me the difference? Yes or no? Actually, at first, when we are using transformer, okay, just concentrate for the difference, because when we are using transformer, for this transformer there is primary side and secondary side, right? We are either stepping up the voltage or stepping down, right? No. So what is happening means your primary side voltage is different and your secondary side voltage is different, right? So whatever be uh, means whatever be the cities, okay, used, that will be also having different turns ratio. Okay, that cities will be having different turns ratio. Means when we are using transformers, their primary and secondary voltages are different, but when we are considering the generators, so for the generators we are using the same voltage, right? Means the primary side means here, mm, uh, uh, before this line, transmission line, so whatever we are grounding this winding, so at here also this voltage is same, and we are using in this transmission line, whatever cities we are using for that also, that voltage is same, means voltage is not changing there. Okay, voltage is not changing here, just like the transformer. Okay, but for transformer, suppose the primary, the transformer is of 33 by suppose 230. Okay, full transformer is there. Then what will happen? So your primary side voltage is different there. The secondary side voltage is different, but it is not for the alternator. For both sides, the voltage remains same there. Okay. Then the turns ratio. Next is the turns ratio. So if we are means if we are using the transformer, okay, then they will means as the transfer for transformer, we are using step up and step down transformer. The turns ratio will be there. So for cities, it will be different. Okay, it will be different because there is a turns ratio of transformer also. Okay, but for generators what will happen, this means the turns ratio for the cities will remain same. Okay, turns ratio will remain same for the current transformers in case of alternator. But when we are using this scheme for the our transformers only, these ratios are also changing. Okay, and next one is the tap changer. Okay, so there is no any tap changer we are using in this alternator, but sometimes when we are using the transformer, so in transformers we are using this tap changer, right? Now, so these are some differences between this alternator, means differential protection of this alternator and the transformer. Okay, so I hope all of you got this mm, differential protection scheme. Okay, so yes or no, any doubt is there? If any doubt you can ask me. After that, next point is the unbalanced protection, but we'll see that point in next lecture because time is less now. Unbalanced protection of alternator is there. Again, some few points are remaining, so we'll see that in next lecture. So, any doubt? Anyone want to ask anything? Okay. So, for now, we'll stop here. Thank you all and have a nice day. Thank you.